We're just setting here.
Yeah, that's not right. The first one is in the data somewhere.
Guys, just so you were aware, you guys are muted.
I think they're just getting everything finalized with the camera and all that.
Oh, okay.
Stakeholder in the solar industry. We want to, you know, we want to do we want to educate ourselves on, in the industry challenges, and we want to follow innovations and share knowledge, right? And so we want to learn from each other. And I think that's the intent of this event here, is to learn from each other and, and, and have a good solutions for our customers, to find a good solution for our customers. I think And we do have a great team from K2, coming in here to spend time with us and show us what challenges are there in commercial solar roofing and discuss with us and discuss the challenges and finding solutions and what they're doing to come up with the innovative solutions to address those challenges. And we're going to talk about how that has evolved over the course of a few decades. And again, what current challenges and what are they doing? And as a team, what we are doing with, to come up with the solutions. So we have Andrew. He's an ASIC certified installer and trainer, commercial systems product manager at K2 Systems. And he has 11 years in solar industry. We got John Riddle, who is a Southwest Regional Manager, 5 years in solar PV, and has a very strong construction background. We have Casey Lewis, Regional Product Specialist. He's 14 years in PV and has a strong EPC background. And he's now as a specialist. So go ahead, John, take it from here.
Yeah, perfect. So we're gonna get into a little bit about who K2 Systems is. Basically, look at the evolution of the solar racking and talk about some PV installation pain points, and then some code compliance and what K2 solutions we want to talk about that we think will help tackle some of the problems and challenges that we talks today. One of the things we like to highlight with K2 Systems is that we are a global provider, manufacturer. And so we currently have 11 locations, physical locations, but service, 4 continents. And one of the real big things that we always like to talk about is, we have 130 countries that we actively provide our material to and have just under 400 projects worldwide. One of the really great tools that we offer is a design tool called K2 Quote and K2 Base. And those that start to use us will have access to this. These are 500 engineering background and embedded service to it. And great tool just to offer to the installer community.
All right. Yeah, let's get into it. So as Lex said, I've been an installer for 8 years before coming to K2 with the foreman on commercial crews. So I've seen a lot of the challenges that we're going to talk about in today's presentation, but we want to open the floor for you guys as well. And ask what type of challenges you guys are seeing. And if any questions arise as we're going through this, feel free to interrupt. I think we'll make this a little more conversational. So yeah, what is a low slope roof or a flat roof? We're going to focus on commercial flat roofs. I've been involved in some ground mounts as well, but today's focus is going to be on what the challenges we see in the flat roof space and some of the solutions we can offer. So what is a low slope, or AKA a flat roof? It's anything that's below a 212 pitch. In roofing terms, 212 is the 2 inches of height of rise over 12 inches of run. It ends up being a 9.5 degree tilt. So anything 9.5 and lower is what we're focusing on today. And then anything higher than that would be considered a pitched roof, steep slope. So let's go through some of the evolution of racking, where it comes from. So some of the early adoption of solar in the 70s and 80s were just using, it was all custom built frame, right? So sometimes wood racking, heavy steel material, just unistrut, available at the electrical supply house. And there was no testing or certification involved, right? So it was all custom. And then in the 90s, In the flat roof specifically, we started seeing the challenge of, you know, wind uplift in roof penetrations and how could we solve those situations where we don't want to penetrate the roof, keep the roof warranty and negate the wind uplift. Well, then early ballasted systems were designed. Moving forward into the 2000s, now cost is more of a concern. We're trying to optimize the systems, the weight and cost. So now we're looking at more lightweight aluminum racking and then further optimization of the systems, not just the materials themselves, but then the speed of installation, and the installation features for the installer and the labor cost. And now we're looking at the solution provided for that would be pre-assembled racking solutions with, benefits and features on the installation side. And then in the 2020s, now we're looking at higher labor costs, and more building code complexity. So what we're doing to address that is more and more testing, more certification that we're seeing, to address those code complexities, and things like fire code and structural code. So like I said in the beginning, it was all custom racking, right? So we call it the Beep and a Prayer era, where you're putting, you can see in some of these images here, we have just wood blocks just sealed to the roof with whatever caulking they had on site. Not roofing approved sealants, just whatever they had, and then angle brackets just attached directly down onto the rooftop with some sealant on top. And then moving forward, there's more. Now we have some code around flashings in the IBC and the IRC. So now installers are starting to use metal flashings, but still no real solar specific design components. They were just using roof boots, whatever you need to see, like on site for drainage pipes or vent pipes. Good enough. All right, there we go. Yeah, and then continuing forward, we had, now we're in the 2000s, early 2000s, 2010s. Now we actually do have solar specific flashings, not just using the OD flashing that you can see, the roof vents. These are now addressing those, the building code compliance, and AHJs are starting to deny, and finance companies are starting to deny anything that's not using these solar specific components. So then moving forward into the 2020s, we have, direct to deck options, rafter options that are using what we like to call flexible flashing. So no more reliance on, the metal flashings. It's no more prying up of shingles, kind of eliminates a lot of that user error, installation error, and really keeping the integrity of the roof intact versus having to pry up tar strips of shingles. And now we're seeing butyl-based designs with pre-assembled butyl bottoms and then similar.
The question about that POA, is it going to come with a lag? Because I know that it must come with a lag, but a little while, but it comes with a lag.
We sell, we provide hardware in most of our components. So with with this guy, will come kitted with number 14 screw. You can get it. So we decided to go with the number 14 screws as our primary option, but we do offer live bolts as well. So if you still want to do the pre-throw pilot hole with the 516 live bolts, that's fine too. We've got feedback from the field, from the installation community was just eliminating that pass, that process of having to pilot hole. The number 14s will self-tackle, will self-drill into the rafter having to get for that. So that's why we decided to pick the 14 screws. You're getting the two of those, you're getting about the same amount of hole I think you would find single flat.
I saw for a while to do didn't come with the POA because they said that order. But now it's all fine.
Well, so depending on the product we produce, either the upcoming extruder or so we have two versions. One called Spike Split, and that one comes with extruders. The version you see on the screen on that right corner, that is our multi-mount. The multi-mount can be installed on a variety of And so depending on the type of rooftop you're installing, we'll take data plans through. And so we've opted to not include hardware so that you're not painted into a corner, buying a screw or not.
We'll talk about that more towards the.
Yeah.
Yeah, so we decided that with that, the newer product, we won't know because of that, it can be multiple. Yeah, we have some concrete roofs here in the southwest of Boston. So
Rather,
you can use the, you know, the patch on or the bullet 12, that's why we decided not to put. Yeah, so we just go have rolls and roll it along. Yeah, right.
Okay, good.
Yeah. So no, kind of.
we got it. And
Okay. Yeah, and this is what, we just talked about this. So yeah, so one of the things that we did is decided to, we go back to the one, use a butyl product, that is UL 2703 compliant. So UL 2703 being, you know, mounting, and clamping systems for, solar, for PV, and 2703 variant of that is addressing waterproofing and runs through various testing and is now UL 2703 compliant. We also have an ICC report on this butyl as well. So if you're not familiar, I mean, we'll talk about the different codes as well, but the International Code Council is the ones who are, you know, writing the IBC, the IRC, who originally had in, you know, these different codes that the metal flashings were the compliant way to deal with these rooftop waterproofing. So ICC is now recognizing flexible flashing as a. Yeah, so we thought this was cool here. So this is courtesy of John Perlin's book here, but this is one of the first racking systems that we know. And it looks like they might have even been using some wood racking there on some solar cells. Actually, yeah, Lek, could you speak to this a little bit?
that's prior 1900, that's 1893 or some time, that's, and it's in New York, that this, the old one, yeah.
Yeah, on a flat roof in New York,
Yep.
high rise, large parapet. I think they were even using gold in some of the bus bars for the solar cells.
One of the antique ones, yeah.
Yeah. But yeah, so this is some of the things we talked about in the prior slides is, yeah, just using some unistrut, going, you know, crossing over multiple layers of rails, and then on the ballasted side too, just basically sheet metal that you're weighing down with ballast blocks. And so now moving forward, we, you know, optimize these systems, be way lighter weight, less materials, and easier to install. So some of the things that we've seen, the challenges that we see, you know, as racking and logistics and ESAS is structural integrity, roof compatibility, you know, finding the right products, making sure that you're code compliant, installation speed, O&M considerations, how easily is a system that you're building maintainable, and yeah, supply chain and cost pressures, right? Having, you know, universal components, less amount of materials in-house, but still being able to find the right solution. So we wanted to ask you guys in the crowd here, what challenges are you guys seeing in this flat roof space? The typical one would be like obstructions, you know, maximizing either the power density or just building around different roof obstructions and the space that you have to work with. And if somebody's flat roof, there's going to be a lot of big HVAC systems or you know, piping systems on the rooftop that you have to work around. Another one being, you know, with those large systems on the rooftops is, you know, the load that you can actually put on these roofs. How much PSF can the rooftop take? Point load as well. But
structurally, if they're, if that's capable or not.
Yeah. But we want to hear from you guys, yeah, what kind of town you guys?
I have a challenge under residential, that would be under 8 now, 44.
Okay.
So, on the residential side, maybe structure.
Yeah, all of our. Right.
Well, this isn't gonna be I mean, this is a flat roof product, but if we're thinking residential, I think more of an optional or a tile. Oh, okay, that's great.
Flat roof.
Yeah.
Yeah, so.
We want to talk high level and then we'll address that later, right?
Okay.
So,
Yeah, so there's a couple different systems. You could use a balancing system and get beneath 8 pounds per square foot for sure. Sometimes it's a little bit tricky depending on the region, the wind load you're seeing. But also we do and go, and we'll talk about this a little bit. There's a mechanically attached system where you can look at it right there, where you're actually fastening into the roof structure through the foam too, even in some cases, or, so we're probably talking about mechanically attached, if we're talking about foam on top that you're worried about. Yeah,
Like we're doing our pound per square foot, we want to know how many ballast blocks, how it's distributed.
yeah, but typically you can get beneath that 8, even with a balancing system. With our south-based system that we'll talk about a little bit. But the other option is always to go with a mechanically attached system and tilt it up. Because you don't want to, on a flat roof, you could go flush mount, but you would want to tilt that up to get the.
You guys are using the kind of install customers are asking specifically to put the building on the roof. Right?
Yeah.
That's a challenge with that. That is underneath that 8 pounds with the foot. Yeah.
I think that should be doable, right? It's even 5 or so.
Yeah,
Difficult.
yeah, on average, will be around, between 5 and 7, yeah, so we can get beneath that 8, and, yeah, we can talk about it, and figure out a couple of applications.
All right.
All right, so what are we looking for in a racking solution? What are the things to keep in mind? One is that wind tunnel testing. Again, go back to your point, keeping that PSF down. Is your system optimized for wind tunneling, wind testing, so that you don't need all of this, a certain amount of ballast blocks on the roof that would bring you over that 8 pounds. UL certification is another one. And through a couple of images up here of some of the testing that you go through with those UL certifications, UL 2703 specifically. And basically throwing flames at the roof, you simulate a rooftops and put your racking system on there. And does the racking system contribute in any way to the spread of that flame? Basically is what they're going for. And happy to say that ours does not. So pre-assembled universal components is, on the installation, the labor side and the cost. And then wire management solutions, we're talking solar here. So there's going to be electricity, there's going to be PV wire, module leads, optimizer, microinverter leads that you have to deal with. And you don't want those things getting damaged in any way or dangling on the roof. You want a certain height off the rooftop for heat concerns. And then O&M considerations, how easy can you maintain the system? There's some of the structural code that you need to keep in mind when designing a system and choosing a racking partner. Is the American Society for Civil Engineers, ASCE 7 in particular, their section addresses wind and snow loads, seismic loads, SBA, Structural Engineers Association of California, specifically looking at seismic activity. And then the International Building Code and the International Residential Code, which address those flashing concerns on rooftops, and the ICC, who writes those codes, and then the National Electric Code, specifically 690, the PV systems code, and looking at rapid shutdown. And then product certifications, another thing that if you want to find in a racking partner is UL 2703. Are they certified to one or two of these classifications, mechanical, fire, bonding, or they're fully listed to the UL 2703 listing. 2703A, like we talked about earlier, with flashing devices, waterproofing. 3741 is a new code or a new listing, new standard, well, newer. It's been around for a few years now, but addresses PV hazard control systems and first responders, firefighters getting up on the rooftop, making those systems safe for first responders. And then waterproofing again, TSA 100, wind, ribbon, rain. And then the material you're using, American Society for Testing and Materials, ASTM, making sure all the aluminum and steel that is going up there is quality. And then some more regional certifications like the Florida Product Approval, FDA, Miami-Dade approval. Have kind of become a standard. You know, is your system going to withhold some of those high hurricane zone wind pressures? So here's what we talked about earlier with that concern about the PSF is you can go with, there's two types of flat roof systems. You know, in general, two types of ballasted system or mechanically attached.
Again, what was the wind speed with the ballasted system? The number of person you showed that illustration.
Say that one more time.
What's the wind speed?
That we can design this to. Yeah, so really, I mean, it depends on a couple factors. So we can design it to whatever we're going to see in the US. So, I mean, even down in Florida, we could potentially design it to that 170 that we're seeing down in Miami. I don't even know if they allow ballasted systems in that county. But we could design it to that, and we could, so there's a couple different ways to address that. It's just, you know, you fill up the chassis with, you know, 5-6 blocks, or we could do a hybrid system where there's attachments mixed in with the ballasting so that you can kind of limit the PSF that you're seeing on for the roof load, mixed in with some, actually, we can see it right there. You know, there's typically an anchor bracket that would be attached to the chassis, and then the roof anchor that attaches to the structure. So there's a couple of ways to do it, but yeah, we could design a system that would meet all of that.
Some of the cities are pushing 110 miles now.
Yeah, no problem, for sure. And we would be at a low PSF at that one. Yeah.
National important thing.
Yeah, and just piggybacking off of that, so the south face system is what it sounds like. It's a south facing ballasted system. So most ballasted systems are going to be south facing, right? You're trying to get the production from the sun, but there are also east west facing systems, and those systems would be even more optimized for the wind pressures. Because if you think about the back end being tilted up, you can add wind screens. We designed the system to not require one, but it does act as a sail when you're tilting up the back end of a system, right? So with an east-west facing system, it's more like a wave on the roof. There are no high end. It's one continuous system. There's no in a row spacing. So that's another way to address that concern is, you know, if you have a PSF limit in a high wind zone, then yeah, if you go with the east-west, the production is going to be a little bit different, right? So those are more optimized for like a time of use situation where, you know, maybe you're getting higher rates in the morning and evening on your electrical bill, and that's going to pull in more power. You know, if you're thinking east-west, right? So in the morning time and then in the afternoon, if people are coming home from work, the power from your system is going to be higher versus a south system. Go ahead. And we'll talk about some of our mechanically attached systems as well here. So this is just a standard tilt-up system as pre-engineering for 7. I think it's actually up to 35 degrees now. So this is a little bit older side, but yeah, so pre-prescriptive engineering, and we could go higher to just might require wet stamping. But in this region, I think, you know, a 20-25 degree tilt is going to be sufficient for the power you guys are going to want to see or produce from your system. Various roof attachments available for these types of systems to address, you know, the different roof coverings, TPO, foam roofs, modified bitumen, and EPDM. there are solutions for all, that'll cover all of those different root types.
Actually, the other one question for the crowd, what is the most common built angle that you try to achieve in this one? I don't, 20. I hear a variety, so I'm always curious, and I think finance plays a little bit of a role. It's that requirement, well, one you've got, one.
So they're actually working on off that question is, so if you're going with the optimal angle, 20-degree angle, what are some of the reasons that you guys would install a balance system that are typically limited to 10 degrees versus mechanically attached?
There's like 6 meters was installed on the roof and it's about like it. I'm not gonna drill through 6, 8 inches of tall.
Yeah.
We're gonna move balance.
So you're just willing to sacrifice some of that production that you can get.
Yeah.
And I think typically on like a balance system, the interval spacing is gonna be less too, so maybe you can fit more rows and maybe for the one factor.
And Andrew, just probably online for
Yeah.
people, if you can reiterate what Brad said, even if there's a big,
Yeah, so, I was asking why, you might sacrifice some of the production angle, the 20 degrees to go down to a ballasted. And, the typical answer would be, if there's, basically just not wanting to penetrate the roof, keeping those roof warranties, intact and not having to, it's a pain, especially if there's 4 days at home trying to find something to drill into as well. You end up having to cut a little bit of the roof up to try to find some. Yeah. On that. So there are tilt-up multi-row systems as well. So that one we were looking at before was just a single row of module. You're gonna have inter-row spacing between each of those single rows. So this is more of like a niche system that takes a little bit of custom engineering. But what it allows you to do is fit 2 rows of modules within a small space. So if you have a lot of constructions or a small rooftop to deal with, and you can't get those 2 or 3 rows of modules because you don't want to have the shading loss between rows where you're dealing with specific spacing that you need between rows, then you can go with a multi-row system and add 2 rows of modules on one racking system.
It's gonna be for smaller.
But we actually basically had customer installing those multi-rows down here, right? What was the reason?
The space,
Yeah.
limited rooftop space, they needed a certain production. So getting that second row allowed them to get what they needed.
And it's the panels from portrait to landscape to the night that they love.
Yeah, like I said, so this is more of a custom, so we could do, yes, a landscape rows, so if you wanted to get maybe 3 or 4 rows of landscape,
Getting outside.
Yeah. And then yeah. And this is also prescriptive, or we can design this to, up to 30, but 20 would be ideal for this region. And, and going back to just the ease of installation and universal components, so the K2's Crossrail system, we use this for our residential systems, has integrated wire management, but you can see on the table here and on the example over there, we designed our systems, our tilt-up systems, to utilize the same exact rail on a flush. So all of the stanchions, all of the posts are utilizing small cuts of that same crossrail. So you can see it on the simple tilt system over there. So if we take this multi-row as an example, we have our cross rails running east-west so that you can mount the panels, but then we also have all of the bracing involved and all of the posts involved are that same cross rail.
Is that a top rail?
Yeah. Yeah, so that's our, and actually, if we go to the next slide, we can talk about that. That's our simple tilt system. So on the crossrail tilt up and the tilt up multi-row, because they're designed in multiple rows on those systems, there's going to be more bracing, more crossrail involved. So typically you have a north-south brace and an east-west brace. Our simple tilt system is designed for just having a single cut to make on that. So it's uses 25% less hardware, less materials, less rail materials, quicker installation, lower labor costs, and yeah, it's just a simpler install. So you're adding, the simple knee is the heart of this system. So there's, and I don't know, this is a new
Yeah, our built-up system is a incredibly strong structure because to Drew's point, you use the north-south and east-west for stabilization. But what we found from the installer community on feedback was it was a lot of material, a lot of cutting. Because we're using our rail, we don't pre-engineer our legs or the braces because different module lengths, different degree angles that you want to achieve. So it gives you flexibility in it, but you got to do it on an individual case basis. Unless you have 10 cookie cutter jobs, you know, it's all going to be the same. So one of the benefits of moving into this, I always call it our, 2.0, but it's our simple tilt, is the fact that you don't require all those cuts and pieces. You just need a single cut. You can see even back here, which is a back leg for your angle, and that's all predetermined in the installation guide. So if you want a 20-degree tilt, we predetermine it's a 17-inch back leg.
That's why I asked if we cross over, there's no rail on this one.
Correct.
For that.
right, exactly, yeah. Yeah, so that is going to remove less material, easy installation, and you're still gonna get good engineering, good standard. out of it. Yeah, so it's gonna be, like I said, you'll be, it's not.
Short answer is no.
Yeah.
But there's
the
a-
tilt-up system.
yeah,
Yeah.
Sorry, but there is one benefit to it where since you don't have your north-south leg, that stabilization, if it gets it real rigid, you can actually, where your front leg, you can stagger for your front and your back leg.
Yeah.
So that will give you a little bit more.
Yeah, it's like have to work, there's a plus here, but the one with the plus over there. The rest of it.
Yeah, yeah. So short answer, no, it's not, but the other side of the equation is you don't necessarily need that.
Yeah, I'm gonna say, I hate to say it, I hate to say it, but it seems like, well, why would I leave this system, but you're still gonna get good standards. And
Right.
we can set up a couple of examples for you, we can show
You
you.
guys still make the cross rail? Like,
Yeah, you can still buy it.
I like it because it doesn't move at all.
Yeah.
I think I feel over 30 years, eventually, if something big a little bit, it's gonna eventually just boil itself out, but that, you can move it all. So, I like it.
Yeah, with all that, there's in there. And like John touched on, it's, we decided instead of just having like multiple part numbers, multiple SKUs for the different tilt legs that you would need for, say you want to do 20, you just certain side 30, a certain side 10, certain side. We decided, well, you can use our crossrail and it's flexible in the sense we can do whatever you want, but if you have quick fitter down, you have a guy in the warehouse, you can just cut a bunch of those up, ready to go.
Yeah. Regionally, you're gonna know. I know I want 20 here in Phoenix. I know I want 10 down in Tucson, so you can pre-cut them. But it becomes cost effective as well. You're cutting sticks of rail rather than predetermined
Right.
back leg.
And you're gonna, you're going 4 or 5 rows of modules across, and you're gonna have a certain amount of scrap rail that you're cutting off anyway. So whether that's 10 inches, 15 inches, to use those scrap cuts for your post.
But we didn't abandon the old system. We still make it available because you have installers that absolutely.
Yeah, on the next one. Yeah, and so that simple knee has notches in it. The base has 4 notches, and then the piece, the top that holds the rail, has a tab on it that slots into the notches for your predetermined tilt angle. So you don't have guys guessing on site. We provide tables that tell you that if you're using this size module and you want to be at this tilt, cut the leg to this length. That's just set your tilt angle within this piece here, and it's 0, 10, 15, 25. And all predetermined, so it takes a lot of calculation. On the site. Yeah, right, yeah.
was one of the bigger feedback we've gotten from the field is the leg or predetermined in the front and back. And so you'd have one person in the back holding it up, person in the front, get right here, you're perfectly level on the rail. Okay, tighten it. So we wanted to remove that.
And now we're moving into some roof attachments to address the different roof coverings you're gonna see in the commercial space. So we'll go through, multiple lag, dual lag options, single lag options, and then some number 14 screws. And yeah, we'll address, the old style of sealing these roof penetrations, versus, a newer process that we created called VP Armor. So this is our T-foot X. This is right in line with that cross-rail open system where real robust, 2 lags into a rafter. You're going to get great pull-out strength from it. But it's it's limited in the sense that you can only tilt of your system is predetermined based on which way your rafter orientation runs, right? Because it's you have that face, that slot of the T-foot that has to face a certain way. So if we move forward, this is, and we've partnered with ChemLink on the T-foot to provide a solution to waterproof. And you guys, is this a typical solution that you guys use out here? Everybody use this ChemLink?
Yeah.
Yeah, so that's why we figured about that. So then moving forward, we went from the T-foot to now what we call Bigfoot. It's a single lag option. So now you can rotate it 360 degrees. You don't have to worry about the rafter orientation on the rooftop. So you can tilt it, due south the way you want it. And we've paired this. So we partnered with Sealbond, who's been in the roofing space for decades now, the waterproofing space, and we partnered with them to package their Sealbond 490 material in with our Bigfoot and KT Armor. So this KT Armor is now a one-piece design. Like you said, those ChemLink products, not only are they high cost, but with the pain to install, it's a multi-step process. You're having to use the part 1, which is a portable sealant, the coffee tube, the M1 on the bottom side. So we eliminated that and made the armor into a one-piece design that has butyl on the bottom. So now you just peel and stick that butyl down on the rooftop.
All right, pre-install. And so butyl is hydrophobic, so water cannot get through it. And so when we partnered with them, they and us, from an engineering perspective, wanted to come up with a solution that really put them install rate. Because we all know flat rooftops always have low spot and people are going to get, it's probably something that's going to happen. So by putting a pre-installed butyl on where the penetration is going to go in, it's going to seal that penetration with it. And then we put a second line of defense, and we're talking to Drew's point of, did you get it right? If not, you can do it differently than I do it, differently than he does it. Feeling stick, always the same way every time. So now you got the second layer of defense, hydrophobic, butyl around it, and then the third will be the seal bond before the attack.
Yeah.
So very quick, very cost effective. We go on to an installation manual for the curve that's like for attachment. He's taking roughly 2 weeks. But from a labor perspective, there's a huge benefit. But it's also more cost effective.
Let's take it back to that, because of the air loading temperatures. That air loading temperature, that 4 or 5 years,
Yeah.
start to come loose. That's a crazy temperature.
Yeah, we simulate age testing as well, so we put it through a pretty rigorous testing. The healthy component of this is not high, like just nothing to worry about.
Yeah, the highest, nothing that you're gonna see on the rooftop there, even in Arizona. And then on the low end too, it's rated up to.
But negative like 40.
There you go.
You can install it.
We don't want to install it,
That's not that sure, that I can work with, not the
the stable temperature.
But But to that point though, once that seal bond, and that seal bond cures quickly, like, it's gonna skin over in minutes. That doesn't mean it's fully cured through, like maybe 48 hours. But once that's fully cured, the butyl, the ring of butyl around the armor is really just working to hold that in until that's gonna be the primary waterproofing. So even if it's not going to, that will, that's been, our proprietary butyl has been tested, it's been around for decades actually. And yeah, there's been we haven't seen any issues with it so far, it's been around for multiple decades, and yeah, but once that seal bond is cured, that's gonna be the primary waterproof. So even if the fuel did fail, that seal bond, not that it's going to, but that seal bond.
Should we keep going, just to be, I think we're going.
Yeah, well, you guys,
We think that we have to really trust with the lab. Imagine if this, the measure previewing, will the vehicle count, if you're not even a passenger, will the vehicle count as filling that list pilot hole?
I would say as long as the seal bond covers in this pilot hole, yeah, the butyl will cover it, and that should be fine, yeah, but, yeah, you'd want to be careful, if it gets outside of that butyl.
Nice,
All right, let's-
nice conversation here. I mean, that's great, we have engagements. Thanks, Brad.
Yes, covering it, you're on.
Yeah, so here it is installed. Let's keep moving forward. Compatible with all the major roof types. You're going to see roof coverings, TPO, rolled asphalt, EPDM, concrete, even. Yeah, like we said, really quick installation. So single lag bolt, pre-drill, put your Bigfoot in, and then it's a one-piece design, peel and stick over top of the Bigfoot and fill it up.
No orientation.
So we did, if we move forward, so that's the typical installation. This would be the atypical installation where you're coring through foam. This will not, it's not compatible with anything over that 2 inches, 2.5 inches of rigid foam. So if you see like a 4-inch foam roof, what ends up happening is because the rim of that armor is 2 inches high, then you're starting to bury back the top side of it and you're losing that T-bolt slot. But up to 2 inches of rigid foam, we're still good. We're still attached to that. And warranty comes in the box, right? So this is actually with us and through Seal Bond that you scan this code, this QR code, and then give some product details and have a 25-year warranty. I think it's 15 years, but then you can renew it actually after that 15 for another. So like all of our systems, they're going to be that, to uphold that standard of a 25-year life of the system on the module side, they're all like 25-year. There's a couple of more options for like the foam style roofs that you would see using an OMG power grip with 12-inch long screws like you see over there on the anchor bracket for the south face system. Just another option for low slope roofs. Here's that D-dome system that we talked about where it's east-west facing. So the wind tunnel testing is really good. This is good for systems that are roofing systems that can hold or have a really low like PSF limit. This was actually an install in Nevada here, and you can see so there's one rack of ballast blocks, and these two modules act as a pair of modules that share this loading. So it can basically call it like it's the ballast required is split in half here on these types of systems. Yeah. Looks really cool too when it's on the roof, like a big wave of modules. And then we'll get into our south face system here. And we'll get into, so there's 44 unique design configurations. So this is the model. Design flexibility means simplicity. It's a real easy system to put together. It could be a 2-part system if you wanted to. We have a south edge and north edge custom chassis as well, but really you could get the entire system done with just 2 SKUs, 2-part numbers. So simplicity, and then we added adjustability into it as well that we'll talk about. So one of the problems that we've seen in the ballast to space is restrictive inter-row spacing. So fixed inter-row spacing. Meaning the space between the module rows, right? That's what we're talking about. We're talking about inter-row spacing. Some of them are fixed at 13, 15, 18 inches. And when we designed the south face system, but not all regions or latitudes, or it's not a one size fits all kind of solution that we've seen on the market. So we designed this south face to have 18 to 18 inches of adjustability in that inter-row. Yeah, so optimized for regional design criteria, not just regionally, but what are the customer demands? Flexibility, just having the design flexibility. Does the customer want as much modules, power density on the roof as possible? Do they want to just cram those in there? Go to the 8-inch spacing. If the customer's more concerned with not the amount, but any shading loss that they're going to see in December, January months, then you can bump that up to 15, 18 inches. So it's just giving the customer, it's tailoring the design to the customer. Another problem is perimeter obstructions, right? So now you're cutting into those fire setbacks that you're going to see on the roof. This has to deal with code compliance, right? And this is going to eliminate maybe a couple rows of modules that you could see on the rooftop. If your ballast, your racking is sticking out, then you could be possibly limiting the amount of modules you can get on the roof. So, like I said, actually, if you go to the next one, we designed a southern edge chassis and a north edge chassis that now tuck the ballasting underneath the modules and eliminate, when it used to be that 20 inches of racking sticking out, now it's just a little power density comparison, and we can scale this up however you need to, but let's just, for example, let's say this yellow line here is our fire setback to code, whether that needs to be 3 foot, 6 foot, 10 foot. Let's just call it our fire setback. And now on the left side here, we're using an 18-inch inter-row spacing. We're just using the single ridge chassis, so we have those sticking out on the north and south edge, and we got 25 modules on this rooftop here. But in reality now, because the racking is sticking out, we're having to eliminate an extra row of modules, so now we're down to 20. And if we look on the right side here, our optimized version of the system, we have that custom south edge chassis and north edge chassis that's tucked underneath the array. And now we've adjusted the inter-row spacing to 8 inches, and we're able to fit 10 extra modules on this small example. We've run some helioscope comparisons to highlight this as well, where we're getting 660 modules on the left side here at that inter-row, that 18-inch inter-row in landscape. And then we have the portrait design, portrait orientation at 8 inches, getting us 850 modules. So it's 40%, almost 40% increase in modules. But again, it just depends on what the customer needs are, right?
And it's flexibility. One system, they can do 2 different varieties of install.
Another thing with these ballasted low slope systems is, multiple parts, a lot of different parts to put on it. And I've been, like I said, I've been performing for 3 years on these commercial crews, and almost inevitably every time I had, a couple tables set up, 10 guys just assembling parts before they even get out of the rack. So that's something to keep in mind, having, that labor cost of guys having to pre-assemble or not pre-assemble, but assemble clamps and chassis to get them ready to even go out into the array. So we address this in the next slide there. The Southwest system, the next one actually, same thing, just way too many parts. So like I said, this is a 2-part system. You can use just the ridge chassis if you want. You are going to have that sticking out on the south port. So, but a 2-part system, you're using the same cross clamp that we use, again, going back to eliminating SKUs, eliminating part numbers, just making just efficiency in the logistics and design, just having one clamp that does it all. So you can use this cross clamp on all our different systems, including not just the residential, but our commercial and balance systems also. And so it's going to come with pre-installed roof pads as well. So that's another worry, on the challenger side is how are you gonna, address the, potential to damage the rooftop? So we address that by adding these roof pads pre-installed on the chassis. So you don't have to put those on yourself. It's gonna come palletized with those installed on it. And then installation features too. You want to make it easier on the installers, cut down on labor costs. So like I said, we have those pre-installed roof pads that are stackable for roof installations. And then we also added an alignment tab to keep the array square, but not just that, also to stage modules before having to torque any clamps down. So you stage the modules on these alignment tabs, it keeps it nice and square, your array, but then you can work on wire management before and make adjustments before you need to clamp them on. Now we're talking about materials. One of the other problems we've seen is corrosion and galvanization on the rooftops, using some of these other ballasted style systems or plastics and polymers that, you know, who knows what's the long-term structural resilience of those systems. And then stainless steel is another option, but that gets extremely expensive. So moving on to the next, how we've addressed that is using a ZAM steel. So ZAM is a zinc aluminum magnesium coating. It's kind of like an in-between between stainless and galvanized. So galvanized you see a lot in ballasted systems or in like ground mount systems. But the ZAM, so what the ZAM does is but with galvanization, you can still see some corrosion, some rusting on the materials. With ZAM, to eliminate that corrosion and rusting on the materials, it's like a thin film coating that actually on any cut or exposed edges of the steel covers that cut edge and acts as a coating that resists that corrosion, that rust. So ZAM is used in multiple industries. We're not the first ones to come up with it, but it's a great in-between between stainless and galvanized. Yeah, and then the obvious problem is, you know, roof damage. So what causes that? You know, wind vibration, seismic, thermal expansion and contraction of the materials. So there's, you know, limits on how big the array sizes can be before you have to have those thermal breaks. And then the roof pads that we pre-installed on our chassis absorb some of that wind deflection, that thermal movement as well.
The poles are designed to remove the water of it. And then if you get a freeze and frost zone where you get some ice in there, it's meant to avoid. So as that ice and water gets in, it freezes and expands and melts, and then to absorb it versus like pushing the material and causing that system to block up.
We actually, this is a patented design that we adopted from Cape, Germany, German engineering, and we shrunk it up a little bit, but it absorbs that all those buildings. And then, like I said, it's a two-part number design, but we have accessories if needed. So we conduit clamps to run any raceways on the east-west. You can install ray tray or cable trays going north-south. We have an anchor bracket if you need a hybrid system, like we talked about earlier. And then we have MLPD mounting and grounding as well. All concerns that you want to address when designing one of these ballasted systems.
Yeah, so again, tools, we talked about this earlier. We have tools that are available to everybody. They do require just a login, say your designs and or download the bombs that you're going to need. But the idea with our K2 quote tool is that you can do it in a minute or less. That was the whole idea. You're on your cell phone, you're on a smart tablet or your laptop. It's really quick, super intuitive. We've got the images of what rooftop, what type of mount you're going to use. It's got your modules in there that are already preset, but if you need to do custom ones, we allow that as well. You can drag and drop the rooftop right onto the image. And, if you want to get into the weeds, we do have an engineering page that'll allow you to select some more of the project details. But we don't, within the K2 quote tool, again, it's a quick 1 minute or less bomb tool. But that's going to be available to you.
And then, yeah, so this will spit out spans. So it does have some engineering in the background, but it's mainly just a BOM, bill of materials tool. And then lastly, on the next slide, we have our K2 base tool, which gives a full structural engineering analysis. So this would be like the BOM tool, the K2 quote, we could design our flush mount systems, simple fill systems. But when you're talking more of a ballasted system, then you would want to use our K2 base tool to get those specific loads that you need to see or average PSFs that you need to hit or be under. And it gives you a full layout of how to lay out the chassis, the dimensions, the spans between the chassis, depending on the module input that you put into the system. And it'll give you a full ballast layout as well, and then give you some of that PSF data.
Color coded. It's highly technical tool. The tool was built from an engineering perspective first, and then a BOM second. So we offer training on this tool because you probably want a little bit of time for us to walk you through it. And we can also help design the system. So, but we do give you full access to it.
Does anybody use either of these tools? Yep. Yeah. Just create a log and save projects. We're back. Yeah, and that is it, I think. Yeah,
That's the end of it.
that is.
Well, I guess we're open for any questions. Back and forth. Thanks for the.
And I would just like to say, like, feel free if we can do some Q&A right now. Also, feel free, we can show you guys, walk you through, the design parameters. We obviously have it set up here in our landscape, but it's designed to be both a landscape and a portrait system, so it does accommodate both.
And then we do have a lunch being served, so feel free to.
Was there any questions that came through?
So there were a couple of great questions, and we're gonna give a Starbucks gift card for the engaging with, so I think Brad will, here, I'll let you guys.
Now,
No biasness.
We did ask some questions about the system itself. I've got one that I think is always really important to ask. With our tilt-up system, one of the benefits that we have that we touched on in creating these tilt angles is that it's custom. What is unique and makes it custom? You have to remember. Yeah, so the back leg is the rail. Yeah, so you cut it wherever you like it.
For the same rail you're using to mount the modules is what you're using as your back post, your back leg. Yeah.
Any other question you want to throw or did you want to run? See if anybody knows the answer.
Is there any other challenge? Was there anything that we didn't touch on that you guys wanted to ask about in this presentation? Okay, yeah, close. We didn't focus on it. Yeah, that's a whole nother presentation. This was more focused on this flat roof. Sorry, but we can. Yeah, we do have a 3-inch pipe ground mount that we can talk about.
Perfect. All right, perfect. Well, Tony had a question, Son had a question.
All right. Good question. We're working on that right now to get the manufacturing and the transforming of the chassis in there. Not today. The answer is no. Currently today, no.
Today, no. This system. I would say in that system.
Yeah. But we could see, I mean, who knows, we're working on it right now, but in another month, we might come out with new guidelines.
So does that mean you've been affected by the new tariff that was set yesterday?
Yes.
We all really unfortunate.
Globally, we source from a lot of. Because of our footprint as a manufacturer, being a global provider, we source where each one is at. This has been asked many times. We diversify as a part of supply chain.
Yeah, I'm holding to it, but, so let's say that you insource it, if it's in the United States, does the 25% really offset the cost, or is it really going to be higher than 25% they pay in the United States? They're paying outside the United States. At 25%.
Yeah.
Yeah,
I don't know the answer. I know that it is more costly to bring it here to the US.
More than 25%.
Right, so we have a double, we have a tariff on the raw material, and we'll have increased labor costs. What's that?
Incidental. Our customers are below.
yeah. No, we're working on it. Yeah, I don't have an ETA on when that's gonna be available for this system. We have rail, like, if you're doing mechanically attached systems, our rails, we offer DC. Rails, great software. So I can't read it. What was the name?
Sean?
Yeah, it's good. So we have domestic content. It's just this system in particular is not ready yet. But our rails, our components, our hardware, we have DC. Yeah. So if you're doing a mechanically attached system, you might be able to meet that.
This is something good.
Yeah. Well, we're trying to make it, you know, kind of make it head on to the. So, right.
Well, we're in this new era now, where it's like, if you ask how much of different medium, and you can't afford it. So if you're asked how much it's going to cost, because of it, trade, and then probably can't afford to buy it. It's going to go up everything. Yeah. But it's nice to just make it there, but that helps.
Definitely, yeah.
Yeah, so to Drew's point, for the residential, for any of the penetration type systems, yes. We assemble, we do all the compliance, that's a made in America product. This particular software system, not yet.
Not yet. I would say so.
Well, thank you everyone for joining us. I think we can get the conversation going. We got lunch over there, so, you know, more time to like just, you know, involve in Q&A and look at the product more closely, and any questions, ask away, please. But we can move on to the lunch.
And we can, we can talk about, we can get hands on too and look at these systems, and take it all, take some modules off and underneath the hood. Yeah.
And thank you everyone for attending our webinar, and we will follow up, well, everyone who's registered, we'll follow up with the live recording of the webinar, and yeah, thank you for joining us. Have a great day.